Cool. Right. Evening, everyone. Thank you for joining me to have a rant about Azure Front Door. No, I'd started doing this before Azure Front Door almost destroyed the world. So it was something that we were actually starting to do as part of like our application development within Acora. So my background is more data. So data, the dirty word on the market at the minute, AI as well. And I kind of look at things more from a problem solving perspective rather than like a pure infrastructure or networking side. So I have an understanding of networking, security and infrastructure, but it's not my core background. So I kind of wanted to just talk through this, some of the things that we've learned more so from a before, the kind of things that have happened with Front Door and just how we're seeing what we want to do from a kind of enterprise application development, more from a kind of data and AI targeted lens. But we're seeing Front Door and a few other services as being kind of core of that, what we're calling the AI Center of Excellence, which I'll kind of tie everything together at the end around. If you've got any questions, feel free to kind of shout at me halfway through as well, rather than just holding it to the end. I'm going to probably sway a lot because I don't like standing still for talks, but Richard has told me that he wants me to stand here so he can record me. Usually watching me is like watching a tennis match, but that's fine. I'll try and stay in one place. So who's familiar with Azure Front Door? Oh, cool. Do one of you guys want to do the talk instead? Hey, sick. So Front Door is a global service. It's got built-in web application firewalls, and I'm looking at this more from the kind of standard premium services rather than the classic that Microsoft have. Caching and CDNs, which I had no idea what that meant until someone from the web team told me that I need to be thinking about content delivery and making things nice and efficient. I was like, I don't care, it's just data in Power BI, right? And then apparently there's a whole web application world that I don't understand. End-to-end TLS management, a load of other things. Some of the things that I'm kind of looking at and are useful for us is around the health probing, smart routing, and a lot of the kind of web application firewall components that are coming in and giving us, for the infrastructure and the applications that we're building, some of that security that makes our CISO, who has left, so I can complain about security, happy. Damn, this is recorded. I need to be polite. I'll remember that at some point. So who use it? I think this is true. I basically went on and tried to find companies that were complaining that they were struggling with some of their applications. So Microsoft definitely use it. And it's not like the good old days when Microsoft created Sentinel and it took them like 2 years or something ridiculous to move into Sentinel from whatever SIM that they were using before. So it's kind of the backbone of lots of different services that we use day to day. So Office 365, LinkedIn, Xbox, Minecraft. Do Microsoft own Minecraft now? I want to say yes. Yeah. Okay, cool. But then other kind of key services like Helm for charts and looking at Kubernetes if you're crazy and want to do that. Sky, Asda, Lloyd's, Acora, the company that bought Elasticloud, and loads of names. There's so many names that are using Azure Front Door as part of their app service delivery, and there's great reasons to be using it as well. So what problem is it trying to fix? So there's quite a few that it's trying to fix because it's kind of a couple of services smooshed together into one. But kind of high latency, poor global performance. So if you're looking at distributing your application over multiple regions, so you've got users and customers that exist in the US, but also in Canada, Europe, and the UK, you want them to be able to get to your services as quickly as possible. You want as low latency as possible. Regional outages, degraded services is another good use case. So if something is going wrong in North Europe, you can start to offload all of your traffic from North Europe to West Europe or wherever else you've got your backend services hosted. So it's great for a high availability pattern. And that's one of the core reasons that we're kind of using that to deal with the application that we're building that I'll cover later from a kind of failover perspective. So we've got high performance across that. Unsecure, inconsistent traffic. So everything goes through a WAF. As you get into the premium SKU, you get a load of managed rule sets that are super powerful. There's a few gotchas within that are quite fun that we've started to realize in the last kind of few months, as well as we've got users doing end-to-end testing. Multi-regional routing management. So as you start to get into more complex areas where you have lots of kind of weird and wonderful rule-based traffic routing, it's a nice kind of central place to be able to do a lot more of this. And kind of centralizing logging and monitoring, as you've got different web applications across different regions, you've got to make sure that you've got like good Azure policy to get this all centralized. But if you start pushing this through Front Door, then it's kind of a single place to see all of that, to have that visibility as well. Microsoft love a flowchart, and this is quite a good one, I think. So point of this slide is this the only approach? And no, there are lots of different approaches that we would look at for specific things. So this is from Microsoft Docs. What did I do wrong?
Can you start again? You're not sharing.
Oh.
Already start from there.
Oh. Sure. There you go. You can stitch the slides together in editing. Doo-doo. Customers. Problems. Is it the only approach? No, it's not the only approach. Why can't I minimize this now? Good Lord. That can go there. Fine. So depending on the use case, there are multiple different services that can exist. So you've got Azure load balancers, traffic managers, API management, application gateways, Azure Front Door, and then you essentially get into the world of combination of services. So what we're kind of looking at is more the Azure Front Door side. So where Front Door really starts to play well is when you've got multiple regions that exist. And when we're looking at things more from like PaaS side, I want to say, but that's mainly because my brain doesn't work in IaaS. It kind of works a little bit in Kubernetes, but not really. So I'm basically just going to cover this because I am lazy. So that's what we're going to talk about. But yeah, it sits in myriad different approaches, but it's not the only one, which is kind of the important part about this. There are obviously other CDNs and other kind of WAF services that exist outside of Microsoft. Most of the cloud vendors all kind of copy each other. So you get this across everywhere, but we'll cover Front Door. Oh, cool. So where does this sit in an architecture? And again, I try to use as much stuff from the Microsoft Docs as possible because they know things a lot better than me, and most of the time the best practice is kind of pretty good in the cloud adoption framework, and it's super useful. So Front Door sits basically at the very front of a cloud setup as much as possible. You want it to be pretty much the first thing that users hit. You may get into a weird and wonderful like, but what about authentication? And yeah, that's fine. But you want it as close to the edge as possible. It's got global routing, security, performance, and you can do all of that before traffic is even hitting your application. So we can think about this as looking at the Microsoft architecture and seeing we've got Contoso as a domain, and then we're immediately coming into our web application firewall. Our Front Door with a web application firewall under it, and we can start to route traffic however we want across different origins into different services that exist. So that can be within an Azure region. It can go into kind of on-prem if we've got routes that way. It can go into other cloud providers as well if you want to be able to do that. And you can start to route things, have failover in various different routes. So what we're going to look at is mostly just a web app. So I'm going to kind of show a couple of different web apps, how we can create routing between them, how we create strong security boundaries between them as well. So we'll have something that's quite simple as an end product, but this can get exceptionally complex. And you kind of want some strong networking understanding of a platform team to be able to understand Front Door. So Front Door, but as a service, is quite an expensive service. I think it's like 250 quid a month for a standard and like 500 for premium, something like that. It might be high. You look like no.
I think premium's
The 250 and then standard is cheaper.
yeah,
Cool.
10.
The 10.
Yeah,
Okay.
quite-
Oh, it's not. Yeah, it's not too bad, is it? Okay.
Premium, like,
Yeah. But yeah, generally, you can kind of centralize this. You can put cost in one place. It's better. There's a weird and wonderful like throughput pricing model as well, where you have like the standard kind of cost of the service, and then you can have throughput pricing on top of it. This is again just from the standard premium rather than the classic, where the pricing model is like per WAF and it's more about individual front doors. How? So throw the cat amongst the pigeon. Who knew that Azure almost ended the world 2 weeks ago? Everyone? Yeah, cool. The second time in 4 weeks, I want to say, that Front Door was responsible for, and I'm being facetious here, it didn't almost blow up the world. But yeah, there was a lot kind of happening within a few weeks. So it kind of started off bad for Microsoft with Front Door going down and taking lots of things down. And then they got to kind of squirrel away because an AWS region went down, and that was the new worldwide disaster. And then Microsoft did not capitalize on that opportunity and broke Front Door again. So yeah, it was quite big. Acora are a managed service provider as the kind of default of what the organization does. Thankfully, we do not have to get involved in that because it sounds really boring. But we were just leaving the office as this was kind of starting to happen. And I think within the space of like 2 hours, they had like 4 or 5 customers raise like P1 incidents, and all the sales team were all panicking, and we're like, it's probably just Front Door is broken again, and there's not much that we can do about it, but we understand why customers are very upset. So yeah, lots of things went down. Richard Aaron complained that he couldn't access Minecraft, or is he over Minecraft now? Over it. That's fair. So yeah, lots of things went down, but I think the elements that Microsoft has done really well with this is that they document what's happened. They're very transparent with the things that have happened. They're really quick at the recovery. So I was talking to someone in the office an hour before this happened, and we've apparently had customer conversations where they're like, oh, should we be thinking about how we fail over from like Office applications into Google Docs when this goes down, and blah, blah, blah. It's like, no. From the perspective and time management, that oh, but we're a legal firm, and if we're not billing for X amount of hours, then we're losing all of this. And it's like, yeah, but at the same time, you probably can't even email your clients because they're probably using Office 365. And great, you can default back to using Google services, but you probably can't talk to 90% of the world anyway. So is there a point? No, in my opinion. I think it's a great service, and realistically, there are so many Microsoft services that are the fundamental backbone of organizations that if something like this goes down, it's kind of just suck it and deal with it. There's not much that we can do about it. Customers from an MSP perspective don't really like hearing that. They're like, but we're the most important people in the world. And we're like, yes, you are. You're lovely, but no one else is spending millions of pounds on trying to back everything up to GCP and random other services, so don't stress about it. So what did Microsoft say to kind of mitigate this? Use another service, essentially. So you can go and put Traffic Manager in front of this from an Azure Front Door perspective. You also have the magical go use something else as well, but the documentation wasn't too good at kind of suggesting what you should be using. There was a view that, and again, in the docs, it kind of didn't say don't use another cloud provider, don't use something like Cloudflare, don't use something like Akamai, I think is the other big one. So it was kind of a bit of a left there to have a think about it. But I mean, that was just one part of the kind of reference architecture. I think the actual docs that they go through from like a service health and pushing out what the actual issues were, how they're going about fixing it is really good. But there's always like some weird and wonderful marketing people that get involved in weird and wonderful ways. You also get a quite important note that sits in the middle of the documentation, saying that this mitigates risks against Front Door or other providers, but if Traffic Manager goes down because of a global failure, you're also in trouble. So I kind of was a leaning question for people to have a thought about, which is global services like static web apps, like Azure Front Door, like Azure Traffic Manager are incredible for the convenience of kind of the distribution and the services and tools they provide. But are we getting to a position where potentially we're too reliant on things that we as users don't actually have any control over, and we have to build quite complex architectural patterns to be able to deal with an issue at a global level? So if there's like a region that goes out, it's relatively easy from a high availability pattern. I am not sure what Microsoft's kind of rollout of services is, but I don't think they kind of just do change that gets rolled out to every single data center within seconds for like Cosmos and various different other services. But certainly this happened from a Front Door perspective quite quickly. So more of a thought kind of element rather than me trying to give you a specific piece of advice here. So what does it mean in practice? So there's a few kind of different approaches to this. In Azure native way, you can kind of put app gateways in front of this potentially. They're regional, not global services. It's probably going to be a decent chunk of configuration to get this working in a nice, consistent way. There are other not Azure services that would cover this kind of other service box, but it doesn't mitigate the traffic manager risk. So Cloudflare, Akamai, Fastly, and there are various other CDN WAF providers that exist. So it's essentially taking your Front Door configuration and replicating it into another service. So if Front Door goes down, and this was not even going to be part of my talk until 4 weeks ago. So it kind of shows that, I mean, Front Door has been a service that existed for ages, right? And I wasn't even thinking about having content to do with this, but it's just what's happened. And I think it's important that we talk about it. So there are other services, but again, would I? Maybe, it depends how critical it is, but it's going to be a pain in the ass for an infrastructure perspective. And I don't like a pain in the ass. Cool, so let me go through a demo. So unfortunately, because I do data and AI, I've built a really simple AI chatbot. I'm really sorry about it. I hope that you are not too upset about this. So my team, we do lots of kind of small demos, POCs, MVPs. And again, I try to instill laziness into all of my team as much as possible in terms of let's not rebuild the earth. And if there is something open source that we can use to get a point across to a customer, then let's go and use it. So I'm using a web app, which is a tool called Chainlit. It's super useful for building chatbots, yay, and very little else. So it was something that was created in the AI era. It was owned and managed by open source, but by a company called Literal AI that I think have folded now. So they're trying to find new maintainers of the Chainlit repo, but we use it for a lot of things, essentially. So I have a relatively, if I remember where my code is, simple service. So I'm running this as a fast API application. So most of what we write is Python. I don't like Python as a programming language. I really like C#. Anything that is not compiled makes me want to cry. But this is what everyone does in AI engineering. So this is what we're doing. So we've got a really simple application. We've got 2 endpoints. One of them, health check, which is super important for what we're doing from a Front Door and from a failover perspective. And then we've got a really simple API/chat, which is invoking using LangChain an agent that basically has no prompt. It does nothing of interest, but it exists if you want to see it. This is all it does. It has a super simple tool that basically says it's sunny everywhere because we live in Mars, I don't know, whatever. It invokes a GPT model and it just wraps that as a tool and says you're a helpful assistant. So it's doing nothing of interest. You would never use this in a real world application, but it's not about the AI, it's about the front door. And then from Chainlit, if you're not familiar, you basically have a couple of decorators. So what I'm doing here is just on a start of a message, create a thread ID that's a random GUID. And then on a message, so when a user types something and sends it, get the thread ID, which is stored as like a user session variable, and then go and invoke this and respond with the last message that the agent has. And then the only other bit is a enter auth bit, because I've hosted this in Azure. I don't want just any rando person to be able to access it, even though I'll kill it after the demo. So that's pretty much it. What that looks like locally, I will show you very quickly. Come on, I should have started this before, shouldn't I? Oh, asset hosted, sorry. It pops up with a link, local host. So there's nothing on root. There is a super simple component on health that just returns status okay. There is our chat application, which is hosted here. So I can say hi, and I'll get a response back saying, what do you want? And then because we're using Fast API, we get for free Swagger docs, OpenAI specification docs as well. So because I put a couple of nice kind of property only classes in here, I get what my request body is, etc. And then importantly, the health check as well. So because the front door has a nice warning on it at the minute saying, although service management restrictions have been lifted, it can take up to 45 minutes for your changes to propagate. My live going to deploy this demo is a pre-deployed demo, just in case something went horribly wrong. So what I have here is a premium Azure Front Door service, and it's relatively simple. There's not much going on with it, and it's connecting into a couple of backend API services. So if I show you the graphic that I wanted to, which is here, this is essentially what I've built out. So we have Azure Front Door at the very start. We've got a web application firewall in front of it. Got two different backend services, one in UK South and one in Brazil South, and then they are basically just consuming an Azure OpenAI instance. Brazil South, because we have an office in Brazil and I've never deployed anything in Brazil. So I was like, there's a good use case for doing something in Brazil, but no reason otherwise. So from a resource group perspective, this is exceptionally straightforward. It is literally two different web apps with two different app service plans, the Azure Front Door instance and the web application firewall. And that's all I need. You can obviously make this quite complicated. The kind of full AI infrastructure approach that we were kind of using from a dev test perspective looked something more like this. The use case that we had is that we were trying to put an AI chatbot in front of our third line support. So instead of people going directly into like a service desk that sit across various different places across the world, we wanted them to go into a chatbot first to try and pull the kind of core information out and then create tickets, create incidents in ServiceNow and pass that off into those individual people. So a few additional bits, enterprise apps for auth, containers, because we were doing weird and wonderful PowerShell things to be able to do graph calls, because some of the things that you want to do from a from an Office 365 mail distribution list, I want to say, you can only do with PowerShell commands and there's no API for it. So we had to host this as a Docker container in an app service, pain in the ass, but irrelevant to this. And then the underlying service but for this, we're going super simple. So if we start off by looking at our front door configuration, we come into my origin groups. So what I've set up immediately is just a default origin. And what this is my destinations. So I'm basically saying that for pretty much everything at the minute, because I don't have any other origin groups in there, I'm not trying to manage 5 different applications that you can, that I want these 2 different backend services, which are just my Azure web apps that I showed before. And I have them both enabled. They have different priority ratings. So Azure Front Door has a workflow that it goes through essentially to work out how it distributes traffic. The first part of that workflow is to see whether your origin is healthy, to see whether your host is healthy or not. So at the minute I have 2 different hosts. Both of them are healthy because they're both running, they're both up. There's no problems that I know of with Azure at the minute. So that should pass for both of them. Then you come into a priority. So I've set this as my kind of priority here. So it's got a high priority of 1. This has a priority of 5. You come into waiting after that. So there's a workflow to work out how am I distributing into various different services. So I would expect everything at the minute to route into this one service, which I've hosted in UK South. We've got a health probe on here. So I'm telling it, hit this health endpoint, do it every 10 seconds and use a get. So essentially, if that returns at 200, absolutely fine. It's happy. It keeps it in there and we can go and use it. If it starts to degrade for whatever reason, if it returns 404, 403, 500, whatever it is, it should pull that out of the pool and it should start to route traffic into my Brazil instance instead. Cool. So what that looks like is relatively simple. Does this zoom? Yes, cool. So this is my UK app. I can run a get on that. So I'm just looking at the health check. It's absolutely fine. Perfect. My Brazil instance, run a check on this. Absolutely fine. Perfect. Front door, I'm going to run health on this. And what this is going to do is to push back into one of the services. So I should expect this to be successful because both of my services are up. That's great. What I'm going to do now is I am going to kill my UK South instance by just stopping it, basically. It's the easiest way to kind of test a failover to make sure that your services are still running. So it'll take a few seconds for this to actually go and die, but we should start to see relatively quickly that I'm getting 403s, 403, 4 something to say that it's not alive anymore. Or a timeout maybe. That'll be one of them. But what we should see from 503, yeah. That's from this one. So what we should see here, okay, fine. So this hasn't failed over yet, which is an ideal, but can take 10 seconds, maybe a little bit longer sometimes. So if we try and hit this again, maybe. Yeah, there we go. So now it's failed over to that second Brazil South instance. So we're passing everything off into our secondary instance. Our UK service, if I try and hit this now, is disabled, 403. But my front door traffic coming in via the URL here is going off into my secondary service in Brazil, which is exactly what I want it to do. It's giving me that failover that I need, which is perfect. The other components that you kind of get from Front Door as well come around the security components. And for us, we're really interested in that because we want as much as possible to try to centralize our security. We know that we've essentially got a few different domains of applications as an organization. We've got internal facing and we've got external facing that will go across our entire service desk offering. And we know we want more or less the same rule sets that exist within either side of that. So Front Door is nice for this because it means that we can have dev teams building into production in multiple different ways, whatever services make most sense for them, but then we can start to manage the security in a single place. So what Front Door will start to do is to give us web application firewalls that exist with this. So we're coming in and creating security policies. If I come into this, it's relatively basic at the minute. I'm using the Microsoft managed rules, which on the whole are really good. They give you a lot of really good defensibility from common attack vectors like SQL injection, script uploading, things like that. They've got quite a few around bots as well. And you've got the capability, which is strongly recommended, to tune these individual rules to your specific workflows as well. So the way that you generally do this is by switching the methodology, the mode of what your web application firewall is doing. This at the minute is in prevention mode. So it means that anything that is blocked for whatever reason just won't get through. Detection mode will just basically dump everything into log analytics. So you can start to go through and work out what rules are being hit. Is that an issue with the way that you've developed your application, or is it something to do with the actual usage? What we've realized in our use case is that mostly it's to do with usage, but there's probably not much that we can start to do about that. I'll explain in a sec. So this will then sit across whatever origins you enable this for. So you create an association of your web app, to your Front Door instance, which origin specifically. So I'm saying that I want everything kind of covered by this at the minute. So the custom rule that I've added into this is a really simple IP filter, essentially. So this is the IP address of the local Wi-Fi here for Acora. And what I'm basically saying is that I only want this IP allowed, deny everything else. If there's anything else that's coming in, I want you to deny that immediately. So if I do the thing that makes our SOC get angry at me, which is to pick random countries and VPN in from it as an impossible traveler, this will probably go to Ireland because that's usually the thing that I use at the minute. But it's fun. So I've now connected to a different IP. So my IP is this, so 194.88.100.149, which is not the same as this value. So when I'm trying to come in now via my Front Door instance, what this should be telling me very quickly is that this request is blocked because I do not have IP access into this service on a VPN on a completely different IP, so I can't get into it. So it's kind of the front door of our security components as well. So one of the things that I've shown you here is bad practice, and that is from my service perspectives, I'm able to basically bypass my front door. So at the minute, I can still send direct requests into my two web applications. This one is disabled. Let's not worry about that. But my Brazil South instance, I can send requests to it immediately. I can come to the Chainlit application that exists under this. So if I copy this and come to chat, bang, I'm in. Completely bypassed my front door. Yes, success. Bad development. So there's a few kind of, has anyone used like AWS IAM before? Yeah, it's horrible. It's terrible. So I really like the Microsoft stuff because you just go, here's my service, give it an IAM role. But in AWS, it's weird and wonderful because you have to tell the service that you're calling to that you want to give this identity access, but you also have to tell the identity that it has access to that service. So you have to replicate it in both places. It's horrible. I really dislike it. I kind of feel the same about parts of the configuration with the networking for Front Door, that you do have to make sure that you're actually securing your networking restrictions to Front Door, as well as putting your restrictions on Front Door via the web application firewall. So at the minute, my inbound policies are enabling access from all networks, which is why I can completely bypass my front door instance. I have done a, oh, I haven't, it didn't save. No, I have to remember how to do this live. So what I'm going to do is essentially enable specific rules. So I'm going to put this down and not kick it over. And I'm going to say front door rule. Let's give it a priority of 100. We're going to set this to a service tag, and that service tag will be the back end of front door. Now, what we will also do is we will add a specific identifier for front door. So if we just enabled this service tag as it is, it would basically allow anyone that had deployed a front door instance to still be able to come into our backend service, which we do not want. So what I'm going to do is every instance of front door comes with a specific GUID, an ID, and that is essentially sent as a header into the underlying calls, and you can access, or you can set rules on those specific headers to say I only want these front door instances. You can do up to 8. I didn't pick that number. Don't know why that number exists, but you can have up to 8 front door instances. So what we have now is an allow rule for front door and a deny rule for everything else. So hopefully, if I remember how this works, it should be fine. So again, I'm on the IP that should not allow me access. So yeah, front door blocked. Come back to my Brazil service, then forbidden. So I'm now forbidden from coming into that because I'm not coming in via front door. If I disable, oh, that means that I leave Teams meeting as well, apparently. Am I still sharing? Yeah, I'm still sharing. That's a good one to know for future demos. So if I come back here and try and access service directly, should still be forbidden. Hopefully front door will work, and crossed. I'm going to say it's taken long enough that it should probably work. Thinking about it, maybe, let's just say it did. It's fine. We'll come back to it. But it's that kind of multi configuration that sometimes trips people up. You'd obviously potentially be thinking about doing this through private link as well. So front door premium does support private link. So when you're in that true like enterprise hub and spoke environment, you're probably going to have specific private endpoints that exist in front of your app services, and you can hook all of that together through front door as well. So it nicely ties and marries together the kind of networking as well as the security over the top of that. And yay, me talking for long enough meant that it did work. Great. So yeah, that's kind of high level overview of front door. One of the things that I do want to talk about quickly, has anyone got any questions before I talk about something a bit weird and wonderful? No, fantastic. I thought I had an extra slide. Oh, I was going to show whimsical, that's why. Okay, fine. Cool. So what we're kind of looking at is how do we bring together various different components that mean that we've got users in front of, we've got our customers are able to use Teams to start to get 24-hour support that's super quick. It's not reliant on people kind of being at the desk, and they can get answers really quickly. They can raise incidents, they can raise issues, whatever it is. So everything that we do is bootstrapped through ServiceNow. That's where all of our incident management is, etc. There's a few bits that we kind of want to do to make sure that we're secure from a customer perspective. We want to make sure that if we're doing anything on the tenant on behalf of a customer, because we're looking at like automation of actions as well as users being able to come to us. So we want to potentially have the capability to do things like add users to distribution lists through automation, through agentic AI. So we want to use a specific IP so we can tell a customer, if we see this service principal doing stuff on your tenant and it's got these permissions, if it's coming from anything but this IP, red flag, go through the SOC immediately. So that's a kind of outbound side. Inbound will come through Azure Front Door. But one of the elements that you get through Azure Front Door and through the web application firewall is all of these lovely built-in rules that you think are going to be exceptionally helpful for stopping threat actors, for stopping people coming in and doing nefarious things on your tenant, which on the whole is completely true. What we start to notice is when we're doing basic things like having a joke telling agent, right? So this is going to be fine. There's going to be no issue with this. There's no real rules that this should be hitting over. Tell me a joke. Sure, here's one for you. Did the scarecrow win an award? Or why? Because he was outstanding in his field. Yay. But things that are completely standard for service desk completely blow up from a front door perspective. So this is apparently one of the blue screen of death error codes. So this might genuinely be something that a customer has, and they would be asking us, I've got this error message, can you help? And once they send that from Teams, it comes into ServiceNow, it comes into our APIs. Oh crap, it's blocked. And it took us a little bit of time to go through and diagnose this. And it is one of those weird oddities of what we're getting in the AI age. So the rule that's blocking this is essentially there's one about, whoops, that's not what I wanted. That's definitely not what I wanted. I even threw a bottle on the floor somehow. Hex. Yeah, so there's SQL hex encoding identified. So that's essentially what has happened. Front Door has picked up that in the body of our request, there is hex from SQL. That's a bad thing. And it means that we're blocking the request. We've noticed all sorts of things where there's like weird and wonderful error messages that come up that are just like horrific pages where you get like HTML embedded error messages that users are copying that have like SQL select statements in there, and then pow, front door blows up again. So it's a really good service, and the WAF elements are incredible, but it's taken us quite a while to go through that detection process. So it's essentially literally the flip of a button and the flip of something from bicep as well that changes from detection mode into prevention mode. But it's a really fine balance for us thinking about what are we content pushing out to users and to customers. We're in an okay place with this because we wrap everything in ServiceNow. So we're using what ServiceNow call their virtual agent. So essentially, we're using that to bootstrap through Teams to make sure everything goes through the correct user profile, the correct organization into our backend services. So it means that if something does blow up and we do get the, what is it, 403? Yeah, 403 forbidden, then we can at least pass that back to ServiceNow, and ServiceNow can just tell the user, oh, I had an error. But it's that kind of thought that goes with it of the balance between what rules do we want to put in place? How do we want to make sure that we're still secure and that we're doing the right things, but having usability as well? I think before the AI age, it was a lot more simple because there was more consistency, there was more understanding, apart from like messaging services, as to the types of things that be coming through our APIs. But now that there's a freaking chatbot to do everything and anything, and they're all bootstrapped through app services or container apps or whatever, that it's a lot trickier to understand what rules should we be enabling and disabling for the AI age. Did I miss anything?
For me,
Probably, yeah.
sorry if you remember. You know the rule that you detected starting to show errors?
Yeah.
How did you come to find that without very much of like just having to scroll through all the rules, or did you have to detect it?
Yeah, so so there's various different logs that you can enable on the service. It's on the front door, isn't it? So what we have from a bicep perspective, I haven't enabled it for this, but you get various different diagnostic settings, same with pretty much every Azure service. So this is the kind of, I think this is the key one. So we've got a custo query that is essentially show me everywhere where there's been a block. And what you get from that custo query is here's the individual rule that's actually hit it. It gets a bit weird and wonderful because it actually hits two rules, essentially. It hits the individual managed rule, but then it goes, there's an anomaly. And the anomaly is the thing that actually fires and does the block. So you do get like a little bit of duplication, but if you ignore all the stuff that's like, here's your anomaly, you can see which rules have fired. There's different weightings to some of the rules as well. And I think the algorithm is documented somewhere to say like what level of thresholding needs to come up from various different rules for it to actually fire, triggering an anomaly. And you can come in and specify whether you want each of these rules individually. So I can say, oh, I want this enabled, disabled, but I can also change the action of this from I just want it logging, or I want it as part of the anomaly scoring. And when you hit that anomaly threshold, that's when you actually get blocked. The custom rules are quite good as well. You can start to enable all sorts of things on this, and you can start to do it for specific like routes as well. So the kind of, you can do rate limiting on top of it as well. So we've kind of looked at the combination of using something like API management for AI token usage, as well as putting like rules within front door to do rate limiting. So you've got both sides of the coin. It's not just about like match block IPs or geo regions. You can put some rate limiting across various different temporal windows as well. So yeah, and you can mix and match various different like if statements within the rules that you're creating. So you can get quite complex within this. From a bicep perspective, it gets a bit spicy when you're doing this, but I mean, if you're used to infrastructure as code, it's kind of fine. It's well documented, like everything in bicep, but I generally find write the stuff in the portal and then look at the template that it generates from a bicep IS perspective. Yeah. Any more questions? Yeah.
Yeah, so if you have a lot of rules that are blocking you because you don't know what messages the customer might be sending in, should you try to wrap or base64 encode the messages to get around it, or are you just working against the firewall so you can't do what it's supposed to do, like the recommendation?
I don't know what base64 encoding does. I assume it would still fire on it.
Yeah,
maybe.
Transform any kind of byte into normal letters.
Yeah, so I mean, as much as possible, I want the WAF and the rules to be working. So I mean, if I wouldn't approach it from a like, what can I do to bypass it from a user message point of view? It's for me, it's very much like, what are my specific applications that I should have rules for? And I think where we've kind of ended up here is that we know from a user support perspective that we're probably going to end up turning off a lot of the rules around like SQL and hex and things like that. But that's the exception rather than the rule. So we're creating another web application policy, another firewall policy that has all of that enabled, and we have to go through like a specific, what's the use case, what's the reason, like it's an exemption rather than like the core approach for us. But yeah, there's just so much from a user support perspective, and I think AI is a weird one because you obviously when you're into like the world of Foundry, you start to have the capability to blacklist within Foundry. You can start to put rules that sit in front of the pure LLM calls to kind of stop dangerous threat actors as well. So yeah, AI is definitely a weird one for this perspective from a web application firewall. Any more for any more? Yeah, hit me. You're probably gonna know the answer to this, not me.
You took down paper app, right?
Yeah.
And it's still broke, even though you would think it would just direct the traffic straight to Brazil, right?
Yeah.
Is there a reason why it still gave you that one? Is there any extra measures you need to take to say, like, you check it first before you return me the error, and if it is just redirected then?
Yeah, so there's a few bits. So you have timeouts, but you also have in origin groups what your kind of health check period is over this as well. I was actually quite surprised that this was in seconds, not milliseconds. But I guess it's you don't want to be pinging health constantly. So if I'd have set this lower, I think this actually defaults to like 100 seconds, which is like over a minute and a half. So I lowered this down to 10, but I think this is kind of the core part of where you look at from a failover as quick as possible perspective. So just changing your health check should fail over to that other instance. This is also a bit of a dumb way of doing it. Like I feel like you would probably have two that are kind of priority one and maybe like a complete failover. Can I find the doc that shows the routing algorithm? Front door health check. Is it going to be on here? No. Origin selection. Yeah, there we go. That's what I'm looking for. Cool. So this is the way that it does it. So available backends is done through the health check. So if you lower that down, priority, so you'd probably be in a world where you have multiple. I don't know what would happen if you kind of pointed to a unhealthy that was not health checked and it still, I assume it would still go there within the priority. It would still go there and still give you the 403, but don't know, to be honest. Then looks at latency, then waiting finally. So that's the kind of flow that it does. But yeah, the core thing is you just lower the health check. Yeah.
If I was to fit in Brazil, would it still go to like the UK?
Priority one, yeah, exactly. So even though for you, your latency is going to be crazy high because you're in Brazil and you're really close to it, because I've set that priority rating and priority sits there first, it's still going to route you to UK South because it looks at it before latency.
So I should actually have fragmented thing for both of them.
Yeah, exactly. The main reason that you'd probably want lower priority is for failover that you didn't want to be directing all traffic to always, so more like a redundancy. But yeah, I mean, where we've used it, we just set the same priority across our different instances. We're not so smart as to look at where, for us, it matters less about latency because everything that we're doing is bootstrapped through ServiceNow as an IP, which is hosted in, I don't know, let's say the US for us, maybe. So it doesn't matter whether our users sit in Brazil or they sit in UK, all their traffic is going to ServiceNow for us first. So we're using it from a pure failover high availability perspective. But if you had an actual globally distributed application where people were coming into it directly without something nonsensical like ServiceNow in the way, yeah, you'd want the same priority so you can route effectively. Any more?
In terms of a scale deployment, in terms of like the size you deploy this for,
yeah,
it might come back to the flow chart, to be honest. At what point have you found that there's been any more like regional deployments that are still considered front door rather than, let's say, because I work for customers sometimes that they're purely just more UK based.
Yeah.
They've got out of the UK traffic that's very rare, more free within the UK.
Yeah.
But like, has there ever been a situation where like front door for the consideration there, or more we use web application firewall and implement and the DDoS protections separately, whereas front door seems to have like this packaged approach, right?
Yeah.
So yeah, have you ever used front door in more like a small scale before? Has it always been more for like wider? I guess multinational.
Yeah, well, I mean, So the only real reason that we're using it for the kind of service bot use case at the minute is to deal with a high availability pattern. So traffic that we have from users. So we're in a position where we're essentially running this for the first set of clients that we're testing this through with. So it's not like live on all of the customers that we have. That's like Q1 next year, maybe. But from a testing perspective, we don't need the scale that Front Door has for us. We probably will at some point to have multiple different origin sources, but you're in that, again, weird and wonderful world of like, should I just be using scale out in web apps? But the failover, I think, is the most important part for us. I think for me as a data engineer and a kind of AI engineer perspective, doing things in Front Door makes more sense for me because it's that single service where I can start to define what I would want to do from like a reusability architecture point of view. So one of the elements that Microsoft have within the CAF, and I'll talk about it from an AI perspective, is this kind of AI adoption diagram where I've basically split this in half and gone, the left side is boring to me because it's management consultancy, and the right side is interesting to me because it's infrastructure and AI governance. What they've also documented is kind of this idea of an AI center of excellence. And if you go through this, what the AI center of excellence is, in essence, is building up how you move away from 90% of generative AI problems don't move into production. How do you build an AI center of excellence that means that it's not first past the post in terms of who gets all of your quota for UK South in that subscription because they deployed first? How do you make it repeatable and scalable so you're not part of the 90%, but you're part of, I don't know, 50% of your POCs get into production? So it starts off with like a centralized team creating patterns, practices, shared infrastructure, and then it moves more into like a change approval board. That's the kind of way that I read it. So what we're trying to do is to turn that into what we see as like shared service model and application tier, where we've got like inbound management and then AI gateway. So AI gateway, for those who don't know, is basically Microsoft have created a pattern over Azure API management to support generative AI applications. So where we've kind of seen this is I want to have a shared access layer where all of my services come into Front Door, they come into a central WAF, so I can create the default position and then I can be bartered on if I need to disable some of the rules. Then the various different development teams that we have come in and start building in their own application tier. But I want that to be as limited as possible. So I don't care whether you use AKS, I don't care whether you use an app service, I don't care if you use containers. You deal with how you want to productionize your code. You deal with your secrets and any external service or any PaaS services outside of things that I would want to share. The things that I would want to share would be, I don't like the logging, monitoring, and chat history components that Foundry has. I think it's quite limited compared to if you look at like Langsmith or Langfuse from an open source perspective. So we're hosting that containerized in Kubernetes, where the credentials and access to that come through from key vaults, app configuration stores, and the same to get into like various different models. Like you tell me, I want a GPT 4.1 model, and I go, here's the endpoint in the API management, here's the auth that you need to get into it, which is mostly managed identity, but shared service layer into AI gateway. So I think for me, the long answer or the short answer to the question is I still think there is use for it in smaller use cases, but I see it as being the foundation of like so many things if you can get it right. And for us, we've really struggled with so Elasticloud as an organization was a pure consultancy before. We were never of the size where we had to think about like dog fooding our data and AI solutions. So we had a teensy tiny CRM in HubSpot. We had hundreds of SharePoints, documents everywhere, but we never really had to deal with it because it was all, we did work for customers. Whereas with Acora, as an MSP, there's lots and lots of data that they have that is actually really valuable in terms of service delivery. So now we're starting to dog food solutions, but what we found quite quickly is that there's just like pockets of development in areas, which is really positive. But then when we try to centralize it and create security around it, it's an absolute nightmare and it's hard to get into production. So yeah, I think even from a small use case, it makes sense to think about it up front and then you can build on it after.
Yeah, they still.
Yeah. Right, sorry, I waffled long enough. There's pizza.